Hey guys, Mrs. Traver here. I wanted to look at this worksheet with you that you guys are practicing today. And yesterday we looked at factoring these quadratics from standard form into intercept form. And I wanted to make you notice a couple things before we move on. Let's look at number 3 for a moment. The thing that is different from number 3 compared to our notes yesterday is notice it's set equal to 0. Yesterday we had these all set equal to y. And I want to take a step back and think about what that means for a moment. So when I have a quadratic, what we're really finding with intercept form and going from ax squared plus bx plus c equals 0 and going from standard form into vertex form, a times the quantity x minus p, x minus q equals 0. Notice how each of these are set equal to 0. What I'm really saying is if y is 0, what's x? Well, if y is 0, then it means the height is 0. So really when I set my y equal to 0, what I'm doing is I'm looking for the intercepts. So that vertex form we're factoring into is really telling us what these intercepts are. And that'll be a big goal of ours. So we're going to end up getting used to calling these two intercepts a few different things. So x-intercepts are also known as the following things. They are also known as the solutions. And they are also known as the zeros. So your book, as well as other sources online, will call x-intercepts the same thing. They'll call it x-intercepts, solutions, or zeros of the quadratic. All of these mean the same thing. It is some point, something, comma, 0, where y is 0 and x is something, where it hits this x-axis. And then also, remember, we talked about a few different types. There's 3 ways we could have x-intercepts. You could either have 2 x-intercepts, so 2 solutions. You could have exactly 1 x-intercept, so 1 solution, or you could have no solutions. So those are all possibilities here, and I just wanted to throw that out there for you. So on this worksheet, they're set equal to 0 for that reason. So I just wanted to take a step back and make you realize what we're really doing here. So that's the first thing I wanted to mention. The second thing I wanted to mention is that some of these, right now, the a isn't 1. And I just told you we're only doing a equals 1. So like look at number 2 for a moment, and we're going to work through this one together. On number 2, a does not equal 1, but let's see if we can find a GCF, greatest common factor, something that goes into both 7, 84, and 252. If you can work through that, it is actually a 7. I told you a is 1, and I'm going to make it so a is 1. So factor a 7 out. So if I take 7b squared divided by 7, I'm just left with b squared. 84 divided by 7 is 12, so negative 12b. And 252 divided by 7 is 36. So now this is something that you can factor, and I'll leave you to finish that one from there out. All right, so that's one type that you'll see. Another type that you'll see that looks a little bit different is one like number 1 and number 6 are very similar. On these ones, let's look and see what we can factor out. There's a 5 in common with both of these guys, and there's also at least one v in both. So if I factor out a 5v, if I divide 5v squared divided by 5v, all I'm left with is 1v. And over here, I'm left with a negative 5. All right. From here, this is actually already factored for us because I really have like 5v plus 0 and v minus 5. Notice that this is already in intercept form. So I'm actually all done right here. That's factored. So number 1 is similar to number 6. And let's see, what other ones are there where you have to factor something out? I think that's it. Oh, number 8. Number 8 is similar as well. So 1, 6, and 8 are similar, and then I did the weird one, number 2, for you. You just have to finish it. The rest of these are pretty straightforward. All of them will end up being in factored form to look something like that on each one. And that number 11 and number 12, don't skip it. Those two are definitely doable. They seem like they are random brain teasers, but they're actually not. And if you work through them correctly, they will be a factoring quadratic equation as well. So try those out, and then I will see you guys tomorrow.